अतिथिगण एवं सभा में उपस्थित विद्वान अभिनेतागण, प्रेस मीडिया से प्रतिनिधिगण एवं निर्माता प्रतिष्ठानों से देश के निर्मातागण और अन्य आमंत्रितगण। आज का जो टॉपिक है वो है इमर्जिंग चैलेंजेस इन सिविल इंजीनियरिंग। तो the challenges are multiple and challenges are huge. So this topic is very apt, very relevant. Next slide. So what are the challenges? Let us talk about them one by one. The first challenge is, so the materials have to be used judiciously for their transformation into sustainable development. We cannot go in endlessly, mindlessly, thoughtlessly using the materials. So to understand the gravity of the situation, let's stand this way. The volume of Earth is finite, with a volume of 4 by 3 pi r cube, r being 6,000 kilometers. So the resources are also finite. They are not endless, they are not limitless. And most of the resources are scattered in the outer crust of that planet. So here comes the judicious need of judicious use of resources. Then what is the way out? What's the way? Physics provides the way. And that is, we know that matter can neither be created nor be destroyed. So there is nothing called waste material. But every material gets transformation either physical or chemical. So that's a transformed material. As an engineer, I never use the word waste material. I use the word transformed residual material. So the material which is the end product of one material, one processing industry can be used as raw material for the next processing industry or the next manufacturing industry. Here is the clue. So we have to reuse the material, recycling of the material, and there lies we can meet this challenge. So the next challenge is reuse of materials, recycling of materials, and like we have already been using the blast furnace slag in road sector, fly ash, the residual, the so-called waste of the thermal power plant can be used in road construction. The demolition debris, like Twin Towers of Noida, which have been demolished and accumulated to the vast extent, can be used in road industry as crushed granulated aggregate. Waste plastic, though I want to avoid the word of using waste because that's a transformed material. So waste plastic road industry. So here, reuse of material. Next slide. Then the next challenge is use of appropriate new safe technology. We know that the construction industry is an innovation-driven industry in which new ideas, new concepts, new techniques keep on emerging and evolving every part of the globe in research laboratories. And when these techniques, these concepts, these are given the nod of the approving authority, given the nod of the regulatory body, then that becomes a proven, approved technology. But so what? Before the rollout of the new technology, there has to be some groundwork. We cannot just adopt a new technology, and that groundwork has to be in the form of massive manpower training, massive seminar, massive workshop like this, and right from the laborers level, to the bartender level, to the shuttering mystery level, to the supervisor level, to the construction execution level, to the monitoring level, to the management, top management level. For levels, it has to be a training, a workshop. For higher level, it has to be a seminar. You know, in this ever-evolving world of technologies, nothing is absolute except some physical constants like gravitational constant or Planck's constant. Everything is relative. There is nothing called the best technology. The moment we say that this is the best technology, something better than the best comes out, and that becomes the best. So everything is relative in this world. And we have to keep pace with those changing technologies. That's a major challenge. That's a major emerging challenge of civil engineering. Then the next challenge is The planning must be robust, holistic, with micro-planning at all levels. There is a saying that failing to plan is like already planning to fail. So when we do not resort to planning, that means we are already planning to fail. Isn't it? Do you agree with me or not? Yes. So, planning has to be very robust. So depending upon the scale of planning, the scale of planning must be very high. So depending upon the scale of planning and the size of planning, the size of an investigation, we can have three types of projects. One is TIPP projects, one is MIPP projects, and one is RIP projects. TIPP projects, thoroughly investigated and planned projects. These are needed for mega structures. We can't do without TIPP projects. Then is MIPP projects, moderately investigated and planned project, maybe for a small size or for medium size. MIPP. There is another one which we should not go for. That is the real challenge. That is roughly investigated project. We don't want to use planning in that because in rough investigation there cannot be planning. So those are called RIP projects. RIP projects die a premature death and we say rest in peace, RIP, rest in peace. So the real challenge is to avoid RIP projects. That's a great challenge. We never go for RIP projects. Never be in haste. Haste makes waste. Give enough resources for complete investigation and planning. So the real challenge is to avoid RIP projects. We have to look into that. The construction industry and the relevant departments of the construction industry must take this challenge to avoid RIP projects. The next challenge is one of the project challenges is meeting the deadlines of project completion and avoiding and minimizing the contractual disputes. This is a major challenge. To understand this, let's understand this way that what are the key elements of project execution? There are 4M and 1L. Money, material, machineries, manpower and land. So money, if money is not there, we can borrow from external agencies like World Bank and ADB, so money is not a problem. Material, alternative use of materials can be used. Machinery is not a problem because all the companies are manufacturing good machineries. The problem lies with the manpower and land. So for the mega projects to go through, we need adequate, trained, motivated, skilled manpower, right from recruitment to the promotion. Timely recruitment, timely promotion, and another constant is land. So any physical infrastructure cannot go without land. So we have to focus entirely how to make the land available for the project, either through land transfer or through acquisition or through purchase or something like that. So this is a major challenge. Now, next. Yes. Now coming to what is the goal of engineering? What is our mandate? And you will be surprised to know that our goal is to achieve zero. How can it be? Which we have studied so much of maths, physics, chemistry, engineering to achieve zero. Yes. This is philosophical level of our target. What is that? 3 zeros, super 30. And those are zero incident related to road safety, that is zero accident or zero hazard. This is the first goal. The second goal is another zero, and that is zero defect in construction. And the third goal is another zero, zero adverse effect on environment, that is zero carbon footprint. And when we achieve these 3 zeros, we say that we have achieved, but it's very difficult to achieve zeros. So we say our goal is not zero. As per calculus, it is tending to zero. Perfect zero, it's very difficult. So it has to be tending to zero. The entire journey of civil engineering is towards tending to zero. If you achieve zero, it's okay. Now, next, major challenge. Next slide, please. It's not moving. Yes. Innovation is the core of engineering. To make you understand, let me tell you, let's analyze the word engineer. Engineer comprises of 8 letters, ENG, IN, ER. So IN comes exactly in the middle of the word engineer. And IN stands for innovation. And innovation is the soul of engineering. Innovation is the core of engineering. No engineer can be called an engineer without innovative mind. So innovation is the soul of engineering. Now, what is the requirement? For innovation to go on, innovation is nothing but creativity. Creativity flourishes only in an environment of positivity. Creativity cannot flourish in an environment of negativity. So, for innovation, for creativity, for positivity to move on, there has to be an environment of optimism and bloom. For creativity, research and development to bloom, there has to be an environment of positivity. A demotivated engineer can never do research and development. Every engineer who has done good work has to be encouraged. Then only he will be motivated to carry out research and development due to innovation and creativity. The onus lies on the construction industry and the concerned department of the construction industry. So, this is, I think, I have done a deep dive analysis. I have dived into the unfathomable depth of what engineering is all about. And these are the challenges staring in our face. And we have to meet these challenges. And we will meet this. And now, before I end my introduction of the topic, I would like to tell that this is only introduction. We have technological giants like L&T, like DRN Infracon, like Magic Grid, who will be deliberating in the technical session. So till then, never go away, because the best is yet to come. This is only an introduction of the technical session. Thank you so much.